Okay, so let's take a look at this problem. A tire manufacturer claims that the variance of the diameters in a certain tire model is 8.6. Okay, so if this were all jumbled up on a test, the first thing you'd want to do is identify the parameter. Okay, so this is a claim about variance. Okay, so I know the parameter is going to be sigma squared. Okay, a random sample of 100 tires has a variance of 4.3. At alpha equal 0.01, is there enough evidence to reject the manufacturer's claim? Okay, so I first want to write this as a mathematical statement in terms of the parameter. Okay, so I have sigma squared equals 8.6 because the claim is that the variance of the diameters in a certain tire model is 8.6. So is this the null or the alternative? It's the null. Okay, so this is the manufacturer's claim. So this makes the alternative sigma squared not equal to 8.6. Okay? Okay, so let's go ahead and find the test statistic. The formula is n minus 1 times the sample variance, and that product is divided by the claimed variance. So in the problem, we're given that n is equal to 10, and the sample variance is 4.3. Okay, so far so good? Okay, so we can just plug and chug here. So we have 10 minus 1 times 4.3. Because it's already given in terms of the sample variance, I don't want to square that again. And I want to divide that by the claimed variance. Okay, so putting that into the calculator, do you get a value of 4.5? Okay, so there's our test statistic. All right, so let's go ahead and find the critical value. Actually, critical values, because this is a two-tailed test. So I need to sketch a distribution that's skewed right. Okay, we don't want to draw a bell curve in this situation. And I'm going to shade two areas of rejection. And we're given that alpha is equal to 0.01. So I need to divide that in half. So I'd have 0.005 amount of area in each tail. Agreed? Okay, so I need to go to the table twice because the table reads from the critical value to positive infinity. I'm going to be getting two critical values in this case. So the degrees of freedom will be 9. So let's go ahead and find the upper one first because that's the easier one to find. So I'm going to read down to 9 degrees of freedom and over to an area of 0.005. Okay, do you get 23.589? Okay, so 23.589 for the upper critical value. Now for the lower critical value, we're going to need to figure out the cumulative, well, it's the anti-cumulative area from the lower critical value to positive infinity. Okay, so if I have 0.99 amount of area between the two, then I want to add just that smidge more for the tail. Okay, so in the chi-square table, I want to read over to the column that corresponds to 0.995, right? Because it's 0.99 plus 0.005. Okay. Okay, so looking at the table, do you get 1.735? Okay. So 1.735 for that lower critical value. Okay, so where does our test statistic lie? It's in the fail to reject region. I just happen to be picking ones where we fail to reject. That's not always the case. Sometimes we're in the rejection region. Okay, so our test statistic lies in between. So our decision, based on the critical value method, is that we're going to fail to reject the null. Okay, so to answer the question, is there enough evidence to reject the manufacturer's claim? Actually, no. Because are we rejecting the claim? If we're failing to reject the null, okay, we're keeping the null, right? And this is the manufacturer's claim. So the question asked, is there enough evidence to reject the manufacturer's claim? No. Okay, so there is insufficient evidence to reject the manufacturer's claim. Okay, then you could write what the claim is. Okay, manufacturers claim that ...